Hello everybody, welcome to another Weather Wednesday. My name is Elias and I'm here to talk to you about a very windy topic, and that would be wind. I'm glad that you guys are joining with us today. We are going to have a very fun time talking about wind around the world. Now, if you were with us last week, one of the fun things that I mentioned was that an airplane took off from New York City and broke a record for the fastest time that it took to get to London Airport in England, about 4 hours and 58 minutes. And that, in fact, it went faster than the speed of sound. How is that possible? Well, it was all because of a very strong jet stream. And what is that jet stream? And in fact, what is wind? So that's what we're going to be talking about today. So join me as we talk about wind. So first off, what is wind? Is wind, where does it come from? Is it something that trees create as they blow around? Is it something that clouds create as they form? We have seen pictures of clouds with faces that blow wind, and we think that maybe clouds are responsible for wind. But the answer is that wind is a difference in pressures. And a few weeks ago, we talked about the basics of weather basics. And I want to remind you guys of those because those are going to be very important in today's topic. So the three ingredients or the three basics that I like to talk about in weather is heat, humidity, and pressure, because each of these is related when we talk about weather. First, we live on an Earth that has an atmosphere. And this atmosphere is made up of molecules. These molecules are mostly nitrogen, quite a bit of oxygen, and then some other trace gases, which include carbon dioxide, water molecules, and other things that are in the air. You don't realize that you're surrounded by air all the time. In fact, if that atmosphere was completely still, you don't feel anything. But when that atmosphere moves around, you experience a breeze, you experience wind, because you feel those molecules hitting against your skin, ruffling your hair, moving things around. So when we see wind, when we see the effects of wind, we are seeing the motion, the movement of the atmosphere from one place to another. What causes this motion? That's where these other two ingredients come in, the heat and humidity. You see, when these water molecules in the air, or when these atmospheric molecules, when they heat up, they get more energy and they expand. They need more room. So heat and warm air rises. And when these molecules, especially water molecules, when they rise up in the sky, they create a low pressure. That means more dense air wants to rush in and take its place. So as you get warm air rising, you get cool air trying to take its place, and all of a sudden that creates mixing, that creates motion in the atmosphere. So let's take a look at a few pictures of this and what's happening, particularly on our Earth, and some hypothetical issues too. So first off, some pictures here. Here is a picture of a typical planet. It looks kind of like Mars right now. But let's pretend that this planet is not rotating, not moving. If this planet was not rotating like this Earth behind the picture, if it wasn't rotating, just the warm air rising would rise in the atmosphere up high, and the cool air, which is more dense near the poles, would take its place and come towards the equator. So you would only get a you'd only get a southern or northern, if you're in the southern hemisphere, you would only get that motion towards the equator. That would be all the motion that you would see. But because our Earth is rotating, the air molecules are conserving the momentum and they are moving because of the Earth's rotation. We call that the Coriolis effect. So because of the Coriolis effect, and because the Earth is rotating and all those molecules are trying to conserve that momentum in the direction, we get a turn or a rotation, a slight turn in those air molecules. This is what causes something called trade winds. And there's names for each of these regions of trade winds. You'll notice near the equator, as the warm air rises, right here, as the warm air rises, you have air that wants to take its place. And that's why you get this wind, or this air, that moves in towards the equator. And because of the Earth's rotation, it moves from east to west. So you'll see those trade winds moving that direction. Up here in the more northern hemisphere, or down in more the southern hemisphere, this line is approximately the 30-degree latitude line. You have, for here, this is where the warm air moves towards the cold, right here. Warm air moves towards the cold. The cold moves this way. But as this air moves here, it needs to be taken, the place needs to be taken, and that causes winds to move up this direction. You get a difference in temperatures up here, and that causes the trade winds to move in this direction. There is this boundary here, where there is a distinct temperature change, creates a jet stream. And this jet stream will change, and basically you can think of it as the highway for the weather systems. So this highway, this jet stream, helps to move these systems around, and this is just the general flow that's caused by that warm air rising, the difference in temperature. And the difference in temperature will create the differences in pressures. As the temperature changes on our Earth, north and south, because of the seasons, you will get this jet stream to move around. So you'll see that in our summer, this jet stream, you'll find more warm air down here, and this jet stream will move farther north, typically. In the winter, as there's more cool air up here, the jet stream will move south, typically, and we will have a stronger jet stream in the northern hemisphere. And so you see, right now in the northern hemisphere, we are experiencing stronger jet streams, and that's because of that seasonal change, that strong temperature difference, which creates a strong pressure difference. One last image here, and you can see that difference in temperatures and pressures, creating this motion of air. And when you get this motion of air, you get these almost like rivers going through our atmosphere, traveling from west to east. And so that's what causes the jet stream. So another question that I have is what measures wind? So how do we measure wind? To demonstrate that, I brought along a weather station. Here is an example of a large weather station that you might find on the top of a school or on the top of a telephone pole, different places as you're driving around. If you see one of these things, that is a weather station. Inside here, you'll find different instruments that measure temperature, humidity, pressure. And then on the top, you probably notice this little spinny thing. And this is called an anemometer. An anemometer measures wind speed, or how fast that atmosphere is moving because of the pressure differences and because of the temperature differences. This at the top shows you which direction that atmosphere is moving, which direction the wind is going. But these little cups here, these little cups measure how fast the wind is traveling. Now you can create an anemometer at home yourself. I was working on some anemometers with my kids the other day. Here's one that I made. Here's one my son made, a little bit different, but still able to capture the wind. And then as I gave this challenge to my kids, here's one my daughter made. Now it doesn't look like much, but watch this. Not only does it show me direction, but the angle at which this string flies, kind of tells me how fast the wind is going too. This reminds me of a windsock that you might see at an airport. That little tube that captures the wind. How high or how far up it flies tells me basically how strong the wind is. Now, how these cups or these anemometers work is you need something to capture the wind. As the wind is captured, it rotates. How fast it rotates will tell me how fast that wind speed is. Now, in order to calculate how fast the wind speed is, I need to know the circumference or the distance traveled by these cups. And then I need to capture how many times these cups rotate in a particular amount of time. And how far these cups travel, notice that this one is darker than these other ones. So if I pay attention to this one, I can calculate how many times this one goes around the circle. I can calculate how far that circle is, and then just divide by the amount of time that it took that cup to travel there, and I have wind speed. So an anemometer is a device that captures wind and can tell me how fast that atmosphere is traveling from one place to another. Now I see we have a question on the internet right now, a question for us, and I encourage you guys to submit questions as we do these Weather Wednesdays. I'm always fascinated to see what you are interested in. But one question is, what is the wind going to be like over the next few days? Here in Colorado, we have been experiencing some very windy weather the last couple days. It has mixed with a lot of snow and caused what we've called snow squalls. That's where a lot of light snow comes down, and then the wind picks it up and creates some very whiteout conditions. Very difficult for you to see as you're driving or as see off in the distance. So what is the weather or what is the wind going to be over the next few days? This is a model that looks at wind around the world, and this forecasts what the wind is going to be like. Now, here in the United States, this shows you that general direction of wind, and here you see that jet stream. So what this is showing you is something called the 250 millibar wind pattern, and that means that this is higher up in the atmosphere. So we see up at the jet stream level generally where the winds are traveling. This doesn't quite tell us what the winds are going to be like at the surface where we live. But we're going to post a website that you can look at that shows you what the weather or the wind patterns are going to be like, and you can look at that yourself. So the website that we're going to post is called earth.nullschool, N-U-L-L, school.net, earth.nullschool.net, and that is a website that I love to visit to see what the winds are going to be like at the surface level. So again, jet stream level, we have a strong jet stream over the southern part of the United States. That is going to bring a lot of moisture, a lot of clouds into the southern part. We see this little scoop in the jet stream right here, which indicates a low pressure system up here, and that's going to continue to travel across the lakes and possibly, since it is a low pressure system, probably some snow in the lake system. Over here we see this ridge or this bump in the jet stream. That indicates a high pressure system. So as we back it up here, we'll see that the west coast should have on February 28th some pretty nice weather. And as that moves across here in Colorado, we'll see over about the end of this month, part of March, we'll also see that nice weather coming across. And then we have a pretty significant drop in the jet stream right here. And again, look at that strong winds right here. Again, that demonstrates the difference between cold air and warm air. And we see that dropping straight down from Canada and Alaska. So after the beginning of the new month, after the beginning of March, the Northwest is going to experience some cold temperatures, very cold temperatures, and maybe bring in some clouds there too. So there you see the prediction of the jet stream. And if you want to see predictions of what the surface level winds are going to be, check out that website that we will be posting here shortly. Well, that's all the time that we have for now. Thank you for joining me on our Windy Weather Wednesday. A lot of W's there. Look forward to hearing from you guys. If you have a suggestion on what topic we should cover next, we encourage you to reach out to us. Join us on Facebook, Twitter, and Instagram, and follow us. We love that you guys are watching us, and please share this with your friends and family. Until next time, talk to you later, and hold on to your hats.